Okay, so last Tuesday, so 2 days ago, we looked at conjunction, disjunction, conditional, biconditional, negation, all of that. Our focus was more on conjunction, disjunction, creating truth tables, things like that. Today we're going to focus specifically on conditional and biconditional. So when I say conditional, I mean the right arrow that has the meaning if, then. And when I say biconditional, I mean the double arrow that has the meaning if and only if. So that you will need to know for your test on Tuesday. Conditional is a single arrow, means if, then. Biconditional, double arrow, meaning if and only if. We're going to start today looking at conditional, then we're going to look at biconditional, and then we're actually going to go back to conditional for a short time. Okay, so when we look at conditional statements, a conditional statement which is in the form if P, then Q, although we'll talk about equivalent forms later, there are two terms you should be aware of. The first is the antecedent, or the hypothesis. That is the if P part. The second is the consequent. That's the conclusion, or the then Q part. Now, what's important to keep in mind is we're going to talk later about equivalent forms. What I mean by that is there are ways to write these statements where the if P doesn't actually come first. It's actually the second part of the statement, and the then Q is the first part. But the if P is still the antecedent. So the antecedent doesn't mean it must come first. It means it's the hypothesis or the start of our condition, even if it doesn't come first in the statement. Does that make sense? It will make more sense when you see the examples. Okay, so first page, hi, welcome. Just recognizing antecedent and so if I study for at least 6 hours, then I will get an A on the test. The antecedent, I study for at least 6 hours. And the consequent, I will get an A on the test. So the hypothesis is the antecedent part. The conclusion, or what comes of it, that's the consequent. All right, let's look at the second one. If I get the job, I will buy a new car. The antecedent, I get the job. And the consequent, I will buy a new car. And then our third one, if you can dream it, you can do it. The antecedent, you can dream it. The consequent, you can do it. Any questions on just recognizing antecedent or consequent? And we'll come back to that shortly for when we talk about other forms of these statements. Okay, so then let's talk about the truth value of the conditional. So remember on that prepping for the test thing, I said know the truth values for conjunction, disjunction, conditional, biconditional. And we said for conjunction, they both have to be true to get true. For disjunction, only one. Okay, this is your truth value for the conditional. And what it says is if our if P then Q conditional, if P is true and Q is false, then it's false. That part of it should be really obvious, okay? If I say, if my P is if it's raining, okay, it is raining. Q would be I'm not going to the game. If it's raining, then I'm not going to the game. If P is true, if it's raining, and Q is false, I am going to the game, then my conditional statement, it hasn't worked. It hasn't actually worked out how it said it was going to. So it's false. That piece should be logical. However, we say it's true in all other cases. And the reason for that, the argument for that is there's just not enough information for the other cases to determine true or false. So we say it's true because we don't have enough information to disprove it. In other words, we don't know what happens if Q is first, if Q's are antecedent, and it's true, what happens with P as our conclusion? We don't know. We can't determine that. So we just go with true. That's the piece that I think with conditional can be a little confusing. So let's first look at this, and then we'll look at some truth tables with it to kind of make more sense of this. So determine the truth value of each of the following conditional statements. If 2 is an integer, then 2 is a rational number. Okay, 2 is an integer. Is that true or false? True. 2 is an integer. 2 is a rational number. Is that true or false? It's true. Rational, remember, is like the next one out of integers. So it includes like fractions and repeating decimals and terminating decimals, decimals that stop. So that's like our rational. P is true. Q is true. That's like one of those other cases we say true. If 3 is a negative number, then 5 is greater than 7. 3 is a negative number. True or false? False. 5 is greater than 7. True or false? False. In this case, they're both false. But the argument is the conditional statement, if 3 is a negative number, then 5 is greater than 7. We're not really given enough information to determine if 3 is not a negative number, is 5 not greater than 7? Is that a true statement or not? So because of that, we say true. True in all cases except for one. If 5 is greater than 3, then 2 plus 7 equals 4. 5 greater than 3, true or false? True. 2 plus 7 equals 4. False. This is the only situation that produces an answer of false when we're working with conditionals. Because this is the only one that truly contradicts the conditional. The conditional, by definition, P should be true, and it produces a true Q. So if anything else happens other than that, we have an issue. I should clarify. If anything else with Q happens, we have an issue. Because otherwise, we just assume it's true. All right. So here is our truth table to try to get a little more clarity on what this would look like. P, normal. True, true, false, false. Q, normal. True, false, true, false. Not P, or our negation of P, that's going to be the opposite of P. False, false, true, true. Okay, now we're doing P or Q. So we're looking at these two columns. Since it's or, only one of them has to be true to create truth. So this first row true, second row true, third row true, fourth row false. So true, 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 false. Okay, so now we get to our conditional statement. If P or Q, then not P. This one, I'm going to put a number 1 by it. This is our antecedent. That's the our starting condition. This is the hypothesis. This one, I'm going to put a 2 next to it. That's the consequent. That's the conclusion. Okay. The truth value of a conditional says that the only one that truly violates the definition of conditional is the one that starts true and ends false. That right there creates a false truth value. So if we look at our next one, starts true, ends false, that creates false. Anything else we consider true because we don't have enough information to determine the truth value of it. So true, true, we're going to mark that true. False, start false, then true, we're going to mark that true. The only one that truly violates the truth value of the conditional is if it starts true and it ends false. You got that? Okay. So let's look at another one. P, normal. True, true, false, false. Q, normal. True, false, true, false. Now we have not P, so that's going to be opposite of our P column. So false, false, true, true. Okay, then this one we have Q or not P. So we're looking at these two columns. It's an or, so we just need truth in one of them. We have it in row 1, not in row 2, but yes in row 3 and 4. So we'll have true, then false, then true, true. Okay, so now we have P and Q or not P. So we're looking at this first column of P, and then the column we just did, but it's an and, so we have to have truth in both of them. So here we have truth in both of them, row 1, but row 2 we don't, row 3 we don't, row 4 we don't. So we'll have true, false, false, false. Okay, now we're on to our conditional, which we know because of that arrow, right? So our antecedent, our hypothesis, is this column we just did. I'm going to put a 1 there. Our consequent or conclusion is not P. I'm going to put a 2 above that one. The only situation that truly violates the truth value of the conditional is if it starts true and it ends false. If you find it starting true and ending false, you get an answer of false. Every other situation is true. Questions on that? Okay. So then let's look at an equivalent way, an equivalent form of the conditional. And we're going to see a lot more of these. But remember, we know two statements are equivalent if they have the same truth values. So true, false, true, true. So we see that if P then Q produces, because remember we said the only one that violates is if it starts true, ends false. Everything else is true. So true, false, true, true gives us the same thing if we not P or Q. Or is going to mean either one, and then this will be not P, so it'll be flipped. We'll get the exact same truth value. That means that if P then Q is equivalent to not P or Q. So I'm going to show you how we could reword these statements then. If P, this is our P, then Q. We're going to write them in the equivalent disjunctive form, which is not P or Q. Okay, so if I could play the guitar, I would join the band. If I take my not P, it would say, instead of I could play or I can play the guitar, I can't play the guitar, or I cannot play. I can't play the guitar, or I would join the band. Not P or Q. So if I look at my next one, if Cam Newton cannot play, then his team will lose. My P, Cam Newton cannot play. My Q, his team will lose. So if I want to reword that as not P or Q, I would say Cam Newton can play, or his team will lose. And you should be able to, even though they sound different, you should be able to see the equivalency in the meanings when we write it a different way. If Cam Newton can't play, his team will lose. Cam Newton can play, or his team will lose. Like, the meaning behind it is the same. I can't play the guitar, or I would join the band. If I could play the guitar, I would join the band. Meaning behind it is the same. That's the equivalent piece. All right, if I don't move to Georgia, I will live in Houston. P would be I don't move to Georgia. Q, I will live in Houston. So if I'm going to do not P or Q, instead of I don't move to Georgia, I'm going to say I'm going to change the tense a little bit and say I will move to Georgia. Or I will live in Houston. It wouldn't be wrong if you had said, I do move to Georgia, or I will live in Houston. It's just not grammatically correct. If the number is divisible by 2, then the number is even. My P, the number is divisible by 2. My Q, the number is even. So not P would be the number is not divisible by 2. Or the number is even. Let's while we're on this topic, so skip ahead just a little bit for me. Go to the page that says conditional and related statements. So the only reason I kept it in the order in your notes that I kept it in is because Section 3.3 covers conditional and biconditional, and then Section 3.4 goes back to conditional, okay? So when you go to do your homework, it's going to go in the order of your notes. But while we're on this topic in theory and in our minds, let's just talk about this. So we just did not P or Q. That was our equivalent disjunctive form. There are also other equivalent forms or related statements to our conditional statements. So really, any of these phrases mean the same thing. They're equivalent to our if P then Q. So this is our original, if P then Q. You can take out the then when you make the statement and just say if P, Q. You can say P only if Q. P implies Q. Not P or Q means that's what we just did, right? That's the disjunctive. Not P or Q. Every P is a Q. Q if P. Q provided that P. Q is a necessary condition for P, or P is a sufficient condition for Q. All of these are equivalent. So you can write a conditional statement in any of these ways. And this is what I was saying at the beginning, where your antecedent is your hypothesis, and your consequent is your conclusion. It doesn't necessarily mean that in writing it comes first, the antecedent comes first. Because I can say Q provided that P. Q is still the conclusion, and P is still that hypothesis or that necessary condition to create Q. So this would still be my antecedent, my consequence, but it would be in a different order. So I just want to do a few of these, practice writing them in a different form, just so that you can see that these might show up in a different way. And there's no necessarily like right or wrong. We could use any of these for each of these. But for number one, let's try this one. How would we say number one? Yeah, Jojo. Perfect. Every even number is divisible by 2. Okay. For number 2, let's try this one. How would we say that? Yeah, Elena. Yep. So I would still start with today. So either you can say today is Friday or today being Friday, something like that. Today is Friday implies yesterday was Thursday. Okay, for number 3, let's try this one. How would we say that? Yeah, Hannah.
The sum of x and y is even, provided that x and y are odd integers.
Perfect. The sum of x and y is even provided that x and y are odd integers. All right, for number 4, let's try this one. How would we say that? Go ahead, Hannah.
Living in Ohio, or wait. Yeah. Living in Ohio is a necessary condition for living in Grand Rapids.
I'm going to just throw one word in there, not living in Ohio. And that would be perfect. Not living in Ohio is a necessary condition for living in Grand Rapids. That's supposed to be a C. Okay. These would all be considered equivalent forms. Now, if I gave you one of these on your test and asked you to pull out the antecedent and consequent, you're still like this one. The sum of x and y is even provided that x and y are odd integers. This x and y are odd integers is the necessary piece to produce the sum is even. So this would still be your antecedent, and the sum of x and y is even would be your consequent. Okay, so that's kind of what you're thinking through. We're not going to do a ton of those on the test, especially not the most challenging ones. But I want you to know what an antecedent and consequent are, and I want you to know that there are equivalent forms that you can switch your conditional between, okay? But I do not expect you to have all of these memorized. I also don't expect you to write all of them on your note card, okay? All right, go back to negation of the conditional. So we're still talking conditional here. If P, then Q. If we want to negate that or take the opposite of it, we can say P and not Q, and it means the same thing. If we had a ton of time, we could do the truth tables or a truth table for each of these and show that the truth values are the same. But for sake of time, I'm just going to tell you that P and not Q is going to be the negative of not P, not the, not if, I'm going to say it wrong. The negative of if P, then Q. We're going to go with that. Okay, write the negation of each conditional statement below. So we have if P, then Q. If they pay me the money, I will sign the contract. This is our P, this is our Q. If we want to do the negation of this, the opposite of this, what we're going to write is P and not Q. So we're going to say they pay, and we can kind of change that tense. We could say they paid me the money. And I did not sign the contract. They paid me the money, and I did not sign the contract would be the negation of if they pay me the money, I will sign the contract. All right, let's look at number 2. If the lines are parallel, that's our P, then they do not intersect. That's our Q. How would we negate that? Yeah, Elise? Good. The lines are parallel and they intersect. Which we know is false. So that's how we know we did a good job coming up with the negation, right? Because if the lines are parallel, then they do not intersect. That's our conditional. That is true. If we're going to do the negation of that, the lines are parallel and they intersect, we know that's just nonsense. Okay. If I finish the report, I will go to the concert. So that's our P and our Q. How would we write that? Good, so I finished the report, and I will not go to the concert. Okay, last one there. If the square of n is 25, that's our P, then n is 5 or negative 5. That's our Q. How would we negate that? Hannah?
The square of n is 25 and n is not 5 or negative 5.
Perfect. The square of n is 25. And n is not 5 or negative 5. And again, because that's one we know well, we know that's nonsense, so we did a good job. Okay. So we're going to take a break from the conditional for a minute, and we're just going to touch on the biconditional. And then we're going to switch back to the conditional again. Do you guys want to skip ahead and finish the conditional, or do you want to switch to biconditional and then switch back?
Skip.
Okay, skip ahead. That's what I agree with. Skip ahead and go to this one, statements related to the conditional statement. Okay, so there are 3 other statements that are related to the conditional. They're called converse, inverse, and contrapositive. And I would write this on your note card. And in addition, I would write, we'll get to this chart in a second, and you don't have to write this whole chart, but we're going to record something about this chart that I would write on your note card. Okay, so assuming our conditional statement is always if P, then Q. And that's what you'll see over and over here, right? If P, then Q, if P, then Q, if P, then Q. The converse says if Q, then P. So we don't negate anything, but we switch them. The inverse keeps them where they're at, but it negates both of them. So if not P, then not Q. And the contrapositive flips their position and negates both of them. If not Q, then not P. So we're going to write some examples, and then I want to talk about how they relate to each other. So if I get the job, that's my P. Then I will rent the apartment. That's my Q. Okay, converse says if Q, then P. So if I rent the apartment, then I will get the job. So that's converse. Inverse keeps my P and Q in the same spot, but it negates both of them. So if I don't get the job, then I won't rent the apartment. And then contrapositive flips them and negates them. So if I don't rent the apartment, then I won't get the job. Okay, my question for you is this. Of the 4 statements, right, the original at the top and then the 3 we just wrote, which ones do you feel like share the same meaning with each other? Elizabeth?
First one and inverse.
So this one and inverse you feel like share the same meaning. Do you all agree with that? If I get the job, I will rent the apartment. If I don't get the job, then I won't rent the apartment. Okay? What about the other 2? Do they share the same meaning with each other? If I rent the apartment, then I will get the job. If I don't rent the apartment, then I won't get the job. Okay, so look at that chart on the next page. If you look at their truth tables, the conditional and the inverse are like this reverse of each other. Do you see that? The conditional and the inverse are like this reverse of each other. True, false, true, 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 false, true. The converse and the contrapositive, am I saying that right? Nope. I'm not saying that right. Hold on. Let me see what I'm saying wrong. Hold on. So, in theory, if we look at their truth tables, it's the conditional and the contrapositive that have the same exact truth table. Do you see that? And it's the converse and the inverse that have the same exact truth table. What that would imply is that the conditional and the contrapositive would be equivalent with one another, and the converse and the inverse would be equivalent with one another. Bear with me there while we do the next examples, because then I want to go back to what we just did, because now I'm questioning that. Okay, so decide whether the given statements are equivalent. All that to say, when we talk about what I want you to put on your note card, right? I want you to have these conditional statements. I want you to have which ones are equivalent, because you're going to see statements like this on your test. If a number ends with a 5, then the number is divisible by 5. If a number is divisible by 5, then the number ends with a 5. Okay, our original is if P, then Q. When we look at our second one, what has it done? Switched them. So if Q, then P. What type of statement is that? Converse. Is that equivalent with conditional? No, so not equivalent. Okay, look at our next one. If 2 lines in a plane do not intersect, that's our P, Then the lines are parallel. That's our cue. What has the second one done? Switch them and negated them. So this is not Q. This is not P. What's that one called? Contrapositive. Is that equivalent with the conditional? Yes. Okay. We have one more page of notes on biconditional. And then you have to help me find my mistake on the other page. Okay. So let's talk briefly about biconditional statements. Truth value of biconditional. So, yeah. Okay. Truth value of conditional, we said the only time we get false is if our P is true and our Q is false, that's false. Every other condition, true. The truth value of the biconditional gets a little bit tricky because what it says is it's only true when P and Q have the same truth value. For a truth table, that's easy. If they match, it's true. So if it's true, true, it's true. If it's false, false, it's true. Truth table shouldn't be a problem for biconditional. It gets a little bit tricky if we have statements like this, because what it's looking for is if you plug in, so for instance, this first one, state whether each biconditional is true or false. X plus 4 equals 7 if and only if X equals 3. What we're looking for when we take just a statement and try to determine if it's true or false is we're looking to see when we make one statement true, is the other true? When we make one false, is the other false? So let me show you an example. If I plug in 3 for X, that would say 3 plus 4 equals 7. Is that true? Yes. And if I plug in 3 for my other X, that would say 3 equals 3. Is that true? Yes. Okay, so those match. They're both true. I'm going to make it false now. So let's say I plug in 5. 5 plus 4 equals 7. Is that true or false? False. 5 equals 3. True or false? False. So that matches. Because they match, true, true, false, false, I can say this biconditional is true. With that theory in mind, you are almost looking for a contradiction to prove it false. So look at this next one with me. X squared equals 36 if and only if X equals 6. Okay, I can plug in 6. 6 squared equals 36. Is that true? Yes. 6 equals 6. Is that true? Yes. I could do that and say, oh, hey, they both match. And then I could even find a false one to say, hey, they both match, right? I could say 7 squared equals 36. Is that true or false? False. Does 7 equal 6? No, so that's false. That matches. But can you think of any situation where these wouldn't match? What? Okay, so if I did negative 6 squared equals 36, is that true? Yes. But does negative 6 equal 6? No. So this situation, because it doesn't always match, because there's this contradiction, that makes this biconditional false. So when you're using statements like this, you're almost looking for that contradiction to make sure it's not going to work out. With a truth table, it's easy. The column either matches or it doesn't. Okay, so let's look at the third example. If x is greater than 7, if and only if x is greater than 6. Let's just go right to contradiction. Can you think of any contradiction? 6? So 6 is greater than 7, true or false? 6 is greater than 6, true or false? False. Okay, so that matches. Any others you can think of or you want to test out? 7. 7 is greater than 7, true or false? False. 7 is greater than 6. True. This does not match. This is our contradiction there, so this biconditional is false. Are you tracking with me on these? Okay. Last one. X plus 5 is greater than 7 if and only if x is greater than 2. It's easy to find a true one. 3 plus 5 is greater than 7. That's true. 3 is greater than 2. That's true. It's easy to find a false one because we could even make it 2. 2 plus 5 is greater than 7. That's false. 2 is greater than 2. That's false. Can you think of any contradiction, any time where you would plug in the same x and they would not match? No. So this biconditional would be true. And then at the bottom here, an equivalent form of the biconditional. I just want you to have seen it. I'm not actually going to ask you about the equivalent form of a biconditional on your test, but you've seen it. Questions on that? Okay, good. Now we have to figure out if I made a mistake. Go to this page for me. Okay. Analyze my statements and tell me if any of them are wrong. Okay, so this is tricky, and they would like us to not say won't here, and instead say I didn't get the job. I think that is a little poor. So here was my hang up, right? If we say, according to truth value, conditional and contrapositive are equivalent, then in theory, when we look at these statements, this one should have a similar meaning to this one, and that's not really what we were seeing. They want us to say, if I don't rent the apartment, then I didn't get the job, which would a little bit more match the meaning. It's not very clear to me. Yes? No, we're just going to put a big X through this whole page because I decided I don't like it. Okay? Okay, so your assignment is here. So you have problems from 3.3, you have problems from 3.4, and then you have some review problems. And then you're going to make your note card, and then you're going to come on Tuesday prepared to go over any questions. Make sure you're ready for what the test will bring, and then we'll go from there, okay? Question.